The Alvis Leonides was a compact yet powerful British 9-cylinder air-cooled radial engine, displacing 11.8 liters and producing around 550 horsepower. First run in the late 1930s, it was designed with efficiency and reliability in mind, serving as the smallest member of the Leonides family, but retaining the same robust engineering principles. In action, the Leonides delivered smooth and dependable performance thanks to its radial configuration that provided excellent cooling and balanced operation. Its 550 horsepower output was ideal for light aircraft and helicopters, offering a blend of power and manageable weight. Aircraft such as the Percival Prince and the Bristol Sycamore helicopter demonstrated its versatility. Pilots appreciated its responsive throttle and reliable running characteristics, even in demanding operational environments. The engine's compact design allowed it to be fitted in a wide range of airframes without excessive modification. In helicopters, the Leonides showed particular strength, as its radial layout and steady torque delivery suited rotary wing requirements. During the 1940s and 1950s, it became a trusted workhorse in both civil and military aviation. While larger and more powerful Leonides variants followed, the original 11.8-liter, 550 horsepower model proved the concept and established Alvis as a serious name in aero engine production. The Rolls-Royce Merlin, originally designated the PV-12, Private Venture 12, is one of the most iconic aircraft engines of the 20th century. Developed in the early 1930s, it was a 27-liter, liquid-cooled, 60 degrees V12 engine designed to deliver high power with exceptional reliability. The name Merlin was officially adopted in 1933, following Rolls-Royce's tradition of naming piston engines after birds of prey. At its heart, the Merlin combined advanced metallurgy, supercharging, and efficient cooling to produce a compact yet powerful engine. Early versions generated around 1,000 horsepower, but continuous refinement pushed output beyond 600 horsepower in later wartime variants. A two-stage, two-speed supercharger system allowed the engine to maintain performance at high altitudes, a key factor in aerial combat. The Merlin powered legendary aircraft such as the Supermarine Spitfire, Hawker Hurricane, Avro Lancaster, and the de Havilland Mosquito. Its adaptability and reliability made it indispensable to the Allied war effort during World War II. Beyond aviation, the engine was also modified for use in tanks and high-speed racing boats. The Rolls-Royce Merlin remains a symbol of engineering excellence, embodying innovation, performance, and the decisive role of technology in shaping history. The TPE 331-10 test stand is designed for versatile and reliable engine evaluation. It features a universal engine mount, enabling compatibility with various configurations, and a dynamometer for precise power and load measurement. An optional propeller test system allows for comprehensive performance assessment under real operating conditions. Advanced tools, including vibration analysis and data acquisition systems, provide accurate monitoring of critical engine parameters. Ancillary equipment supports smooth operation, while integrated safety systems, such as drip trays, vibration mounts, and emergency shutdown, ensure safe, efficient, and controlled testing. This setup delivers thorough performance insights while maintaining high safety standards. The 7-cylinder Gnome rotary engine was one of the most iconic power plants of early aviation, particularly during World War I. Unlike conventional stationary engines, the entire engine of the Gnome rotary rotated with the propeller, creating both propulsion and cooling. This unique design allowed for relatively lightweight construction, high power-to-weight ratio, and effective air cooling, making it well suited for the fragile biplanes and triplanes of the era. When running, the 7-cylinder Gnome produced a distinctive roar accompanied by a rhythmic staccato of exhaust. The cylinders, spinning around a fixed crankshaft, created strong gyroscopic forces that affected how pilots maneuvered their aircraft, particularly in turns. While these forces made handling tricky, they also gave the aircraft rapid response in one direction of roll. The engine operated on a total loss lubrication system, using castor oil sprayed into the cylinders. This oil was then expelled along with exhaust gases, often coating both aircraft and pilot. Power was controlled crudely by blipping the ignition on and off, as there was no conventional throttle. Despite its quirks and maintenance demands, the Gnome 7-cylinder rotary was a groundbreaking step in aviation, remembered for its sound, motion, and vital role in early flight. The Grumman AgCat, equipped with a Pratt & Whitney R1340 geared radial engine, has a very distinct cold start procedure, shaped by the design of the big 9-cylinder engine and its geared propeller system. On a cold morning, starting begins with careful priming. The pilot or mechanic first pulls the propeller through several blades by hand, with ignition off, to ensure oil is distributed and no hydraulic lock is present in the cylinders. Because the geared propeller system adds drag and inertia, extra attention is given to making sure the engine is well lubricated before engaging the starter. Once clear, the fuel system is primed with a few shots of fuel directly into the intake or via the primer pump. With the throttle cracked slightly open and mixture set rich, the magnetos are switched on. The inertia starter is often wound up and engaged, spinning the big geared prop until the cylinders catch. As the R1340 fires, white smoke pours from the exhaust stacks while the engine chugs unevenly at first. Gradually, as oil pressure rises and combustion evens out, the radial settles into its deep, rhythmic rumble. A successful cold start is both a mechanical ritual and a sensory event, signaling the AgCat is ready for another day's work. The antique 50 HP Superior oilfield engine is a remarkable piece of early industrial machinery that showcases both durability and engineering ingenuity from a bygone era. Built to power oilfield operations, this massive single-cylinder engine displaces an impressive 463 cubic inches. Designed to deliver a steady 50 horsepower, it was used to pump wells, generate power, and drive equipment in the oil fields of the early 20th century, when rugged reliability was essential in remote locations. This particular engine, now owned by Alan Hazelton, has been carefully restored to working condition and runs smoothly on natural gas. Seeing it operate today is like stepping back in time. Its slow, rhythmic strokes and deep mechanical sounds are a reminder of the raw power and mechanical artistry that once fueled the oil industry. Unlike modern engines, the Superior was built with simplicity and longevity in mind, with a single massive piston driving all of its output. Engines like this are rare survivors, often weighing many tons and requiring careful handling to transport and restore. Watching one in action is not only an educational experience, but also a tribute to the craftsmanship and innovation that shaped the early energy industry. Allen's restored engine keeps that history alive. Howard Hughes' legendary H4 Hercules, better known as the Spruce Goose, remains one of aviation's most ambitious experiments. The enormous flying boat, built largely of birch rather than spruce, was designed during World War II as a transatlantic cargo and troop transport. To lift its 400,000-pound bulk, Hughes relied on 8 Pratt & Whitney R4360 Wasp Major engines, the most powerful piston engines of their era. The R4360 was a 28-cylinder, 4-row, air-cooled radial with a unique corncob layout to maximize airflow. Displacing over 362 cubic inches, its earliest variants delivered 3,000 horsepower, with later versions reaching over 4,000. Starting one of these giants was an event in itself. 56 spark plugs had to fire properly, and fuel priming had to be precise, or the plugs would foul, grounding the aircraft until they were serviced. When Hughes finally piloted the Spruce Goose in 1947, only once and only for a mile at 70 feet above the water, the R4360s roared to life in perfect unison. Though the flight was brief, it proved the aircraft could fly, cementing its place in history. The sight and sound of 24,000 combined horsepower from those colossal engines remains an enduring symbol of aviation's golden age. Der Maybach HL230 war ein leistungsstarker, wassergekühlter V12 Benzinmotor MIT-23 Liter Hubraum, der im Zweiten Weltkrieg unter anderem den Panther, Tiger I und Tiger II Panzer antrieb. MIT rund 700 PS bei 3000 U per minute verlieh er den schweren Fahrzeugen beachtliche Beweglichkeit, obwohl deren hohes Gewicht die Belastungsgrenzen des Motors ausreizte. Charakteristisch waren ein hoher Benzinverbrauch und eine komplexe Wartung, was die M-Fronteinsatz oft Probleme verursachte. Dennoch galt der HL230 ALS technisches Meisterwerk seiner Zeit, das die gewaltigen Panzerkolosse des Dritten Reiches in Bewegung setzte. Ein entscheidender Faktor auf den Schlachtfeldern. The Monte Carlo SS Pro Street is a radical transformation of the classic Chevrolet Monte Carlo SS, engineered with drag racing in mind. At its core lies a high-powered V8 engine, often boosted with superchargers or turbochargers for extreme horsepower. To handle the power, it's equipped with massive rear tires, a narrowed rear axle, reinforced suspension, and a full roll cage for safety. The interior is stripped down to racing essentials, yet the car still maintains street-legal features such as headlights, taillights, and mirrors. With its bold stance, aggressive design, and race-bred performance, the Monte Carlo SS Pro Street bridges the gap between street and strip, offering raw power and an intimidating presence wherever it goes. The Radical Ranger is no ordinary tractor. It's a mechanical monster born to defy expectations. Instead of a stock diesel lump, this beast packs not one, not two, but three Ford Ranger 512 engines, each force-fed by a procharger and running on pure alcohol. That's a cocktail of raw displacement and boosted fury, churning out a symphony of horsepower that could shake the ground beneath any pulling track. The setup isn't just about brute force, it's about controlled chaos. The prochargers deliver relentless boosts, while alcohol fuel keeps the engines cool under extreme loads, allowing the Ranger to dig in and claw forward with terrifying intensity. When those three V12s fire in unison, the Radical Ranger becomes a rolling wall of sound and torque, launching down the track with smoke, fire, and fury. It's more than a tractor. It's a statement that power has no limits. The Gnome Monosoupape single-valve rotary engine, introduced in 1913 by the French company Société des Moteurs Gnome Aéron, was one of the most important aircraft engines of the early 20th century. It was widely used during World War I, powering fighters, bombers, and reconnaissance aircraft. Unlike stationary radial engines, the entire engine rotated with the propeller, improving cooling but introducing unusual handling characteristics due to gyroscopic forces. Its name derived from its simplified valve system. Instead of conventional intake and exhaust valves, it used a single exhaust valve per cylinder. Fuel-air mixture entered directly through ports in the cylinder wall, reducing mechanical complexity and weight while increasing reliability. The Monosoupape design also eliminated the need for a carburetor, relying instead on careful fuel regulation. Producing between 80 and 160 horsepower depending on the model, the Monosoupape was renowned for its power-to-weight ratio, which was critical for early aviation. However, it also had drawbacks: high fuel and oil consumption, limited throttle control, pilots often flipped the ignition to regulate power, and strong torque effects that made aircraft tricky to fly. Despite these issues, the Gnome Monosoupape became an iconic power plant of the pioneering era of flight. After half a century of silence, a rare Mars 5 HP diesel engine has roared back to life. Originally purchased from a cane farmer in Nambour, Queensland during the 1970s, this machine passed through several custodians before finally being restored and started again. Built by the Mars Machine Tool Manufacturing Company of Brisbane, these engines were designed as heavy-duty alternatives to listers. With a 3-inch crankshaft and no interchangeable parts, Mars engines were built for strength and reliability, commonly driving line shafts in factories where listers struggled with twisting under load. This particular 5 HP example still carries traces of its original maroon factory paint. Remarkably, its internals showed little wear, suggesting it had not seen extensive service. Restoration involved new rings, valves, bearings, oil lines, and gaskets, while the cylinder liner was only lightly honed. Careful mechanical work was carried out with the help of Simon de Vere, affectionately known as the Lister Whisperer. Hearing it run again after decades of dormancy was a historic moment. Soon, a cosmetic restoration will return it to its original livery, mounted on a steel transporter to highlight its industrial heritage. From the cane fields of Queensland to rally grounds, this Mars engine is alive once more. The Pratt & Whitney R4360 Wasp Major was one of the most powerful piston aircraft engines ever built, representing the peak of radial engine development. Introduced during World War II, it featured an extraordinary design. 28 cylinders arranged in 4 rows, forming a massive air-cooled radial. Displacing 4 360 cubic inches, 71.5 liters, the engine produced up to 3 500 horsepower in its early versions and later exceeded 4,000 horsepower. The R4360 was developed to meet the growing demand for greater power in large bombers and transport aircraft. Its complexity was immense, containing thousands of parts, intricate cooling requirements, and a unique arrangement that earned it the nickname corncob engine due to its layered appearance. Despite being a piston engine, it approached the performance levels of early jet engines, though at the cost of high fuel consumption and maintenance demands. The Wasp Major powered notable post-war aircraft, including the Boeing B-50 Superfortress, Convair B-36 Peacemaker, and the C-124 Globemaster II. However, by the early 1950s, turbojets and turboprops rapidly eclipsed piston technology, limiting its long-term service. Even so, the R4360 remains a landmark in aviation engineering, symbolizing both the pinnacle and the twilight of large piston engine development. The Bentley chassis Rolls-Royce powered 27-liter V12 Merlin/Meteor Monster is one of the most outrageous and celebrated special build cars in British motoring history. Created in the post-war era by engineer and racer John Dodd and others before him in earlier forms, it represents the pinnacle of the specials tradition, taking war surplus aero engines and shoehorning them into automotive chassis to create machines of unmatched spectacle and brute force. The heart of the monster is the legendary Rolls-Royce V512, either the Merlin, famed for powering Spitfires, Lancasters, and Mustangs, or its tank-derived cousin, the Meteor. Displacing a colossal 27 liters, the engine produces well over 1,000 horsepower in road trim and considerably more when tuned. This power was installed into a modified Bentley chassis, heavily reinforced to cope with the massive torque and weight of the aircraft engine. The result was a car of almost mythic proportions, over 19 feet long, brutally loud, and capable of astonishing speed runs. It wasn't just a stunt machine. Owners campaigned it at events, drag strips, and demonstrations, stunning crowds with its thunderous presence. Today, the Bentley-Rolls monster stands as an icon of British eccentric engineering, blending war heroics with automotive audacity. An old diesel engine startup with fire is a sight both thrilling and nostalgic. In Nepal, some of the earliest fuel engines still survive, used for powering mills or pumps in remote areas. These machines, built decades ago, lack modern starters, so operators often ignite a small fire, or use burning cloth to preheat the combustion chamber. The fire helps warm the metal and thin the diesel for ignition. With loud clanking sounds, smoke, and the smell of burning fuel, the engine slowly roars to life. Such engines symbolize resilience and simplicity, reminding us of a time when innovation was purely mechanical. Even today, Watching one start with fire feels like witnessing living industrial history. The 600 horsepower antique gas engine at the Western Minnesota Steam Threshers Reunion in Rollag, MN, is one of the largest running internal combustion engines in the world. Built between 1914 and 1915 by the Snow-Holly Works of Schenectady, New York, it originally worked at National Fuel Gas Corporation's Roystone Station near Titusville, Pennsylvania, compressing natural gas continuously for over 50 years. This mechanical giant stretches 65 feet in length, weighs 140 tons, and rests on a foundation up to 10 feet thick, reinforced with 8,000 feet of steel bar and 157 cubic yards of concrete. Its 4 combustion chambers, each with a 24-inch bore and 48-inch stroke, displace an astounding 81,388 cubic inches, 1,334 liters, not counting the massive piston rod. Running at just 80 RPM, the engine produces 600 horsepower with 39,000 foot-pounds of torque. The flywheel alone measures 18 feet in diameter, weighing 24 tons, while the 16-inch diameter crankshaft tips the scales at 12 tons. Every Labor Day weekend, spectators at Rollag gather to hear its thunderous rhythm, a rare chance to witness a century-old masterpiece of engineering still alive and running. The Rolls-Royce Griffon Mk58 was one of the final and most advanced variants of the legendary Griffon engine family, developed during the latter years of piston engine dominance in aviation. Introduced in the late 1940s, the Mk58 was a 37-liter, 60-degrees V12, liquid-cooled engine that produced around 455 horsepower, making it one of the most powerful piston engines ever fitted to a British aircraft. Unlike the earlier Merlin, the Griffon was designed to deliver greater power for larger and faster aircraft, particularly in the face of rapidly advancing aeronautical technology during and after World War II. The Mk58 variant was optimized for low-level performance, featuring a 2-stage, 2-speed supercharger and contra-rotating propellers. This combination improved handling by eliminating torque effects and provided smoother, more efficient thrust. The engine's most notable application was in the later versions of the Supermarine Spitfire and the Naval Seafire FR.47, where its immense power significantly boosted speed, climb rate, and overall combat capability. Although jet propulsion soon eclipsed piston engines, the Griffon Mk58 represented the pinnacle of British piston engine design, combining raw power, refined engineering, and adaptability for naval and land-based fighters alike. Out at Norman, hill climbing with the Minneapolis steam traction engine was both a challenge and a thrill. The powerful Minneapolis Moline traction engine, built for endurance and raw pulling strength, dug into the earth with its wide steel cleats, puffing clouds of steam as it inched steadily upward. The rhythmic chug of the engine echoed across the fields, a reminder of early farming grit and ingenuity. Every climb tested the operator's skill, balancing throttle, steam pressure, and traction, while the machine demonstrated its sheer capability. At the top, the view and the accomplishment made the climb all the more rewarding. The Lunenburg Foundry's Atlantic twin-cylinder 8-horsepower gasoline engine was a compact yet reliable marine engine built in Lunenburg, Nova Scotia during the early to mid-20th century. Lunenburg Foundry and Engineering Company, established in 1891, became well known for manufacturing durable engines tailored to the needs of Atlantic Canadian fishermen and small craft operators. The Atlantic twin-cylinder model represented one of their practical designs, offering around 8 horsepower, sufficient for powering small fishing boats, workboats, and coastal craft. As a gasoline engine, it was designed to be relatively easy to operate and maintain, particularly appealing to fishermen who needed dependable machinery under challenging conditions. The twin-cylinder configuration provided smoother operation compared to single-cylinder models, reducing vibration and improving reliability during long hours at sea. Rugged cast-iron construction and straightforward mechanics meant these engines could withstand harsh marine environments and be repaired with basic tools. Though modest in power, the 8-horsepower Atlantic twin-cylinder was an essential workhorse for many inshore fisheries before the widespread adoption of diesel propulsion. Today, surviving examples are rare and often preserved by collectors or maritime museums, serving as reminders of Atlantic Canada's rich seafaring and industrial heritage. The Rumely OilPull Model E was one of the most powerful tractors of its time, produced by Advanced Rumely between 1911 and 1923. Known as the 30-60, it delivered 30 horsepower at the drawbar and 60 horsepower on the belt, making it a true workhorse for large-scale farming. Weighing in at about 26,000 pounds, the Model E is designed for the toughest agricultural jobs, from pulling massive multi-bottom plows to powering threshing machines. Its two-cylinder engine, with a 10 by 12-inch bore and stroke, ran at a slow and steady 375 RPM. Uniquely, the Model E was designed to run on kerosene, using Rumely's innovative oil cooling system to prevent overheating, an advancement that set it apart from many competitors. Farmers often upgraded the ignition system from the original low-tension setup to high-tension magnetos with spark plugs, which improved starting and reliability. At demonstrations like the Bruce County Heritage Festival in Paisley, Ontario, the Model E still impresses audiences, showcasing its immense strength by pulling an 8-bottom plow through the soil. More than just a machine, the Rumely OilPull Model E represents a key step in the evolution of mechanized farming, and remains a legendary tractor in agricultural history. The Deutz MAH711 diesel engine, introduced in 1954, was a robust single-cylinder, 4-stroke engine widely used in agriculture and small-scale industry. Built by Klockner-Humboldt Deutz AG in Germany, it featured air cooling, making it durable and reliable in varied conditions without the need for a complex water cooling system. With a displacement of around 711 cc, it produced modest power but was highly fuel-efficient and easy to maintain. Farmers valued its dependability for driving stationary equipment such as threshers, pumps, and generators. The MAH711 remains an iconic example of post-war German engineering in practical, everyday machinery. Ranger V770 was a 12-cylinder, air-cooled, inverted V12 aircraft engine developed by the Fairchild Ranger Aircraft Engine Division in the early 1930s, with production spanning 1941 to 1945. It featured a two-piece aluminum alloy crankcase, steel cylinder barrels with integral aluminum fins, and aluminum heads, making it one of the few American inverted, air-cooled V-type engines to reach production. The engine displaced 773 cubic inches and produced around 520 horsepower. It saw limited use, notably in the Fairchild AT-21, gunner trainer and trials on the Curtiss SO-3C Sea-Mew and Bell XP-77 prototypes. The Farymann KS diesel engine is a compact single-cylinder power unit designed for stationary applications. Renowned for its durability and fuel efficiency, it operates on diesel fuel, ensuring economical performance over long periods. Its robust construction and simple design make it highly reliable, even under continuous operation. Widely used in industrial and agricultural settings, the KS engine powers equipment such as pumps, generators, and small machinery. Its ease of maintenance and dependable output make it a trusted choice where consistent, efficient performance is required. Compact yet powerful, the Farymann KS remains a benchmark in stationary diesel engine technology. The Brons motor, developed by Dutch engineer Jan Brons in the early 20th century, represents an important step in the history of internal combustion engines. Introduced around 1907, it became one of the earliest practical semi-diesel engines, and played a vital role in bridging the gap between hot bulb engines and true diesel technology. Its most notable innovation was the patented Brons system of fuel injection, which ensured more precise fuel delivery and improved efficiency compared to earlier designs. This advancement influenced later developments in diesel technology and set the stage for modern fuel injection methods. The Brons motor was widely adopted across Europe for a range of purposes. Farmers valued it for powering threshing machines, pumps, and other agricultural equipment, while industries and small ships relied on it for dependable energy. Its semi-diesel operation, however, required external heating to start, typically using a blowtorch on its hot bulb before it could run independently. Despite this inconvenience, its simplicity, reliability, and longevity made it a trusted choice for decades. Today, the Brons motor is celebrated not just as a functional machine, but as a piece of engineering heritage. Restored examples are displayed at engine shows and museums, where enthusiasts marvel at its robust construction and mechanical ingenuity. As such, the Brons motor remains a lasting symbol of early innovation in combustion engine technology. The Packard Bentley Mavis is a one-off engineering marvel created by British engineer Chris Williams. Built on a Bentley 8-liter chassis, it is powered by a 42-liter, 500-horsepower Packard V12 engine from a World War II U.S. Navy torpedo boat. Taking 7 years to complete, Mavis stretches 21 feet long, weighs 2.7 tons, and guzzles 15 liters of fuel per minute at full throttle. Debuting in 2010 at the Cholmondeley Pageant of Power, it became famous for its flaming exhaust and thunderous presence. Today, this fire-breathing giant resides on permanent display at the Technik Museum Sinsheim in Germany. The Leopard 2 is a modern German main battle tank renowned for its power, protection, and mobility. It is driven by the MTUM B873 diesel engine, a 12-cylinder, 47.6-liter, turbocharged, liquid-cooled powerhouse producing 500 PS. This engine, combined with the Rank HSWL 354 automatic transmission, allows the tank to reach speeds up to 68 kilometers per hour and maneuver effectively over diverse terrain. Its large fuel capacity supports long operational ranges, enhancing battlefield endurance. Widely regarded for its balance of firepower, armor, and agility, the Leopard 2 remains a leading force in modern armored warfare and NATO's most trusted battle tank. The 50-horsepower Fairbanks Morse Type N engine is one of the most iconic heavy-duty stationary gas engines produced in the early 20th century. Fairbanks Morse, an American company well known for its industrial machinery, introduced the Type N as a robust and reliable power source for agricultural, municipal, and industrial applications. These engines were typically used to drive pumps, compressors, sawmills, generators, and other large equipment where consistent horsepower was required. The 50 HP version of the Type N was a massive single-cylinder engine, often weighing several tons. Its sheer size and durability allowed it to operate under demanding conditions for long hours with minimal maintenance. The engine was designed to run on natural gas, producer gas, or gasoline, making it versatile for different regions and industries. Its slow operating speed, often only a few hundred revolutions per minute, contributed to efficiency and longevity, while the large flywheels ensured smooth power delivery. One of the hallmarks of the Fairbanks Morse N engines was their reputation for reliability. Farmers, mill operators, and municipalities valued them for their ability to run steadily in environments where downtime could be costly. Many engines were paired with irrigation pumps in the Midwest, or with generators to provide electricity to rural communities before widespread electrification. Today, the 50 HP Fairbanks Morse N is highly prized among antique engine collectors and enthusiasts. Restored examples are often demonstrated at engine shows, where their deep, rhythmic exhaust beats and towering flywheels remain a powerful reminder of early American industrial engineering. The Fairbanks Morse N8 horsepower portable engine was a robust and reliable piece of early 20th century agricultural and industrial equipment. Part of the well-known Fairbanks Morse Type N line, this engine was designed to provide dependable power in rural areas, where electricity and other power sources were not yet available. The 8 HP model in particular struck a balance between portability and performance, making it a popular choice for farms, mills, and small businesses. Built with the hallmark durability of Fairbanks Morse products, the N8 featured a heavy cast iron frame and large flywheels to maintain smooth and steady operation. It was typically a single-cylinder, 4-cycle engine, burning kerosene, gasoline, or distillate fuel, depending on availability. Starting was often accomplished by hand crank, with a hot tube or spark ignition system, depending on the year of production. As a portable unit, the engine was mounted on a skid or wagon frame, allowing it to be towed by horses or later by tractors to wherever power was needed. Once in place, it could be belted to threshers, corn shellers, sawmills, pumps, or even small generators. Its versatility made it a central tool on many farms, essentially serving as a mobile power plant before the widespread adoption of electricity in rural America. Today, Surviving Fairbanks Morse N8 HP engines are prized by collectors and steam gas engine enthusiasts. Restored examples often appear at antique tractor and engine shows, where they demonstrate the mechanical ingenuity and enduring craftsmanship of early power technology. The Davant 4VN is a robust and reliable marine engine, widely respected for its durability and efficient starting system. Designed to meet the demands of heavy marine operations, the 4VN relies on a compressed air start procedure, a hallmark of large marine engines. Before initiating the engine, operators must perform standard checks to ensure smooth and safe operation. This includes verifying oil and fuel levels, opening the fuel valve, and confirming that the engine is set to neutral. In colder conditions, a starter aid may be necessary to assist ignition. To begin the startup, the clutch is fully engaged and compressed air from a dedicated bottle is released into the cylinders, turning the engine over until it reaches self-sustaining operation. Once the engine fires, close attention must be given to vital operating parameters, such as oil pressure, cooling water flow, and temperature levels. These readings are crucial, as they ensure the engine is adequately lubricated and running within safe limits. Proper adjustment of fuel supply and speed control allows the Davant 4VN to deliver reliable power output for propulsion or auxiliary purposes. Its system emphasizes both precision and operator responsibility, reflecting the complexities of large-scale marine engineering. The startup method not only highlights the engine's mechanical strength, but also underlines the importance of thorough monitoring during operation. In essence, the Davant 4VN combines proven reliability with practical engineering, making it a dependable choice for vessels that require consistent and efficient performance at sea. The DT-75 is a Soviet and later Russian-tracked agricultural tractor that gained fame for its reliability, adaptability, and long service life. Produced at the Volgograd tractor plant from 1963, it quickly became the most widespread crawler tractor in the Soviet Union, with more than 2.7 million units manufactured. Its design was rooted in the earlier DT-54 model, but improved with a stronger structure and more efficient components. The tractor's construction featured a welded frame and a rubber-sprung undercarriage, which gave it durability and stability in difficult terrain. The original DT-75 was powered by a 75-horsepower four-cylinder diesel engine, but later models introduced stronger engines, including the 90-horsepower A41 and a 95-horsepower turbocharged version. This progression ensured the machine kept pace with the increasing demands of modern agriculture. Highly versatile, the DT-75 could operate a wide range of mounted and towed equipment, making it suitable for plowing, harrowing, and sowing, as well as for forestry and land reclamation work. Specialized versions expanded its utility. The DT-75B was designed for swampy or wet soils, while the DT-75K adapted the machine for colder climates. the dissolution of the Soviet Union, the tractor remained in production in limited numbers and continued to be used across Russia and other post-Soviet states. Its widespread presence and rugged performance have made it an enduring symbol of Soviet agricultural mechanization, representing a machine that was simple, dependable, and built to last. In a remarkable blend of industrial heritage and craftsmanship, a unique demonstration showcases how a steam engine can power traditional woodworking machines, once central to clog production. The event recreates a bygone era, when steam power fueled not only factories but also smaller workshops, driving belts, pulleys, and line shafts that transmitted motion to multiple tools at once. The steam engine, with its rhythmic pistons and hissing valves, is coupled to a system of overhead shafts and leather belts. As it begins to turn, the entire workshop comes alive. Saws, lathes, and shaping tools spring into action, all synchronized by the steady beat of steam power. These machines, originally designed in the 19th century, were essential for transforming rough timber into the smooth, curved forms of wooden clogs. Visitors witness the complete process. Logs are cut into sections, hollowed and shaped with precision tools, while the smell of freshly cut wood fills the air. Unlike modern electric workshops, the steam-powered system emphasizes both ingenuity and limitation. Machines must be arranged in line with the drive shafts, and speed is controlled by adjusting steam flow. The demonstration highlights not only the technical mastery of steam engineering, but also the cultural value of clog making, a once thriving trade in many rural communities. By reviving these methods, the display serves as a living museum, reminding audiences of the interdependence between early industry and traditional crafts. It is a rare spectacle where mechanical innovation and handcraft traditions converge in harmony. Steve Wright of Southwest Michigan built an extraordinary machine using a 1932 Ford sedan as the foundation, transforming it into a jaw-dropping creation nicknamed Twice Blown Delivery. At its heart are dual Keith Black Chrysler 572 Hemi engines, each equipped with computerized electronic fuel injection and topped with twin 871 billet blowers. Power is channeled through a custom 2-speed power glide transmission by Davant, built to withstand the immense output. With an estimated 500 horsepower, this build is a staggering display of engineering brilliance. Blending vintage hot rod style with extreme performance, it's both a mechanical marvel and a work of art. On October 6, 2012, the Canyon Lake Car Show roared to life in the heart of Temecula Valley, drawing enthusiasts from all over to celebrate engineering, craftsmanship, and pure automotive passion. Among the polished chrome, classic beauties, and cutting-edge customs, one attraction rose above the rest: Wild Fang, the fire-breathing dragon on wheels. This fierce custom creation wasn't just a car, it was a spectacle, with every burst of flame shooting skyward, and every thunderous rev of its engine. Wild Fang electrified the crowd. Its dramatic fire displays lit up the showgrounds, while its raw power and monstrous presence cemented its status as the undisputed star of the event. Children and adults alike stood in awe, capturing the unforgettable performance on cameras and phones as the dragon-like machine commanded attention. Set against the scenic backdrop of Canyon Lake, the show offered more than just cars. It delivered a full sensory experience. Rows of gleaming vehicles, the hum of engines, and the community spirit created an atmosphere of excitement and celebration. But it was Wild Fang, with its fire-breathing fury and beastly energy, that transformed the 2012 Canyon Lake Car Show into a legendary memory for all who attended. Regarded as an icon of Soviet engineering in the latter half of the 20th century, the T-100 crawler tractor bridged the gap between early designs and the more advanced bulldozers that would follow. Introduced in the early 1960s as the successor to the S-100, the T-100 embodied the Soviet emphasis on strength, durability, and practicality. It was built not merely as a machine for agriculture or construction, but as a versatile workhorse suited for forestry, land reclamation, and infrastructure projects across the vast and varied landscapes of the USSR. Production of the T-100 began in 1963, replacing the aging S-100. The new model was powered by a 4-cylinder diesel engine producing 79 kilowatts, an improvement over its predecessor's 74 kilowatts. This modest but significant increase gave the T-100 more pulling power and efficiency, especially in heavy-duty tasks. Many units also came equipped with hydraulic systems, either mounted in the front or rear, allowing them to handle specialized attachments for earth-moving, drainage, or logging. The first generation of T-100 tractors remained in production until 1975, with an impressive 278,101 units manufactured. In 1973, the T-100MS was introduced as an updated variant, borrowing components from the larger T-130 model to streamline production and improve reliability. Enhancements included better steering, braking, and cab ergonomics. Between 1973 and 1983, another 134,044 T-100MS units rolled off assembly lines, underscoring the machine's enduring demand. Even after more modern bulldozers entered the market, the T-100 continued to prove its worth. Its simple mechanical systems and rugged construction made it easy to repair and maintain, especially in remote regions. Special adaptations, such as wider tracks, allowed it to operate in swampy terrain, while exports extended its influence abroad, notably to East Germany. Today, surviving T-100s stand as working relics of Soviet industrial might, remembered not only as machines of utility, but as symbols of resilience and engineering continuity.